So, here's something worth thinking about as you settle in tonight. Somewhere on the western edge of Cairo, right now, in the dark, three enormous stone mountains are standing in the desert exactly where they have always stood. They were old when Cleopatra was alive. They were already ancient when Julius Caesar visited Egypt. Alexander the Great passed by them and said nothing that history bothered to record, which tells you something about how overwhelming they must have been even then, even to a man who had conquered most of the known world and was not easily impressed. The Greek historian Herodotus wrote about them in the 5th century before the Common Era, and described them with a kind of barely contained astonishment, as though words kept failing him every time he tried to get close to the reality of what he was seeing. The Arab scholar Abd al-Latif traveled to Giza in the 12th century and spent a very long time just standing there, looking. He wrote afterward that the longer he stared, the more convinced he became that his eyes were deceiving him, that what he was seeing could not be real.
And here's the thing. The pyramids are still doing that to people. Right now, if you go and stand at the base of the Great Pyramid of Khufu, which is the largest of the three, and the one closest to the northern edge of the plateau, and you look up, what you see doesn't quite register as architecture. It registers as geology. It feels more like a mountain than a building. The base of that single structure covers an area of about 13 acres. Each of its 4 sides is roughly 755 feet long. It was, for approximately 3,800 years, the tallest structure human beings had ever built on the surface of this planet. And it is made almost entirely of limestone blocks, each one weighing somewhere between 2 and 15 tons, fitted together with a precision that, even today, is difficult to explain away as simple craftsmanship. We're going to spend some time with all of that tonight, with the pyramids, with the people who built them, with the long and occasionally eccentric history of trying to understand how they were built and by whom and why. It's a story that stretches from the 4th dynasty of ancient Egypt, around 2560 BCE, all the way through Napoleon's expedition, through Victorian archaeology, through the genuinely strange mid-20th century explosion of alternative theories, through the satellite surveys and ground-penetrating radar of the last few decades, and up to the present moment, where we know more about the Great Pyramid than anyone has ever known, and where it still manages to withhold its most fundamental secrets. Get comfortable. There's no rush at all. If you drift off somewhere along the way, that's perfectly fine. The pyramids have been waiting for answers for 4,500 years. They can wait a little longer. Let's start at the beginning, or as close to it as we can get.
The story, in the way historians tell it today, begins not with the Great Pyramid itself, but with a man named Imhotep, who lived about a century earlier, and who was one of those rare individuals about whom you can say, without much exaggeration, that he changed the world. Imhotep served as chief minister and architect to the pharaoh Djoser, who ruled Egypt during the 3rd dynasty, around 2650 BCE. Djoser wanted a tomb. Every Egyptian pharaoh wanted a tomb, because the Egyptians had a very particular relationship with death and the afterlife, one that we'll get into shortly. But for now, the important thing is that tombs were not optional, and they were not small, and they were not temporary. A tomb for a pharaoh was meant to last forever, which is an instruction that creates very specific engineering pressures. Before Imhotep, the conventional royal tomb was a structure called a mastaba. The word comes from the Arabic for bench, which gives you a rough visual idea. A mastaba was a flat-roofed rectangular building made of mud brick with sloping sides and a flat top, sitting over an underground burial chamber. They were substantial, but they were modest compared to what was coming. And they were made of mud brick, which in the desert will last a very long time, but not forever, not by a considerable margin.
What Imhotep appears to have done, and we say appears because our knowledge of his thought process comes from inference and archaeology rather than from any document he left behind. What he appears to have done is look at the mastaba and ask a question that nobody had quite asked before. What if you stacked them? What if you put one on top of another, each slightly smaller than the one below, building up toward the sky in a series of steps? The result, which still stands at Saqqara, about 30 kilometers south of Cairo, is the step pyramid of Djoser. It is roughly 60 meters tall. It is the oldest large-scale stone structure in the world, and it represents in a single building one of the most consequential architectural leaps in human history, the decision to build in stone rather than mud brick, and the idea that height itself was a form of meaning. Sit with that for a second. Before Imhotep, people built tombs. After Imhotep, people built monuments. The difference is not just material, it's philosophical. A mud brick mastaba says, here is where the body rests. A stone pyramid reaching toward the sky says something rather more ambitious. It says, here is where the body waits to be reborn, and the structure itself is part of the mechanism. The pyramid was not just a container, it was a machine, in the ancient Egyptian sense, for bridging the world of the living and the world of the dead.
Now, here's where things get genuinely interesting, and where the story starts to build toward the Great Pyramid in a way that matters. Because between Djoser's step pyramid at Saqqara, around 2650 BCE, and the Great Pyramid of Khufu at Giza, around 2560 BCE, there are a series of extraordinary, strange, and in some cases catastrophic experiments in pyramid building that the Egyptians conducted as they figured out the engineering and the geometry and the logistics of what they were attempting to do. These intermediate pyramids are not as famous as the Great Pyramid, and they don't get the dramatic television specials, and that's a shame, because they tell you more about the actual human process behind pyramid building than the Great Pyramid itself does. Precisely because they are imperfect. They are the evidence of learning. There is the pyramid at Meidum, built initially as a step pyramid, and then converted apparently into a true smooth-sided pyramid, and which at some point, probably during or shortly after construction, partially collapsed. The outer casing slid off and piled up around the base, and it sits there today looking something like a tower rising out of a hill of its own rubble. Nobody is quite sure whether this collapse happened during construction, shortly after, or centuries later, but the fact that it happened matters, because it tells you something about how hard it is to build a true pyramid, one with smooth angled sides, using the structural techniques available in the 26th century BCE. And then there is the bent pyramid of Dashur, built under the pharaoh Sneferu, who was Khufu's father. The bent pyramid is remarkable and, in the gentlest possible way, hilarious. It starts climbing at a very steep angle, about 54 degrees, and then, roughly halfway up, the angle abruptly changes to 43 degrees, giving the structure a noticeably kinked profile that you can see from some distance away. Archaeologists believe the original angle had to be changed because the foundation was subsiding,
or because cracks were appearing in the internal chambers, or both. The builders looked at what was happening and made the judgment call, mid-construction, to reduce the slope and complete the pyramid at a safer angle. It is an engineering correction made visible in stone, and it is 4,500 years old, and it is still there. Sneferu also built a second pyramid at Dashur, called the Red Pyramid, which is the first fully successful true pyramid. It is smooth-sided, it did not collapse, it reached its intended dimensions, and it must have felt like an enormous relief to everyone involved, because the false starts and the collapses and the mid-construction corrections of the preceding decades had been expensive and somewhat embarrassing, and here at last was proof that it could be done. Khufu, Sneferu's son and heir, came to power around 2589 BCE, and he decided to do it even bigger.
Let's spend a little time with Khufu, because he is, in many ways, a ghostly figure in the historical record, and that ghostliness matters to everything that follows. For the man who commissioned the largest building project in the ancient world, possibly the largest building project in all of human history measured by raw labor input, Khufu left behind remarkably little. We have his cartouche, the oval hieroglyphic nameplate that ancient Egyptians used to mark royal names, painted on stones inside the pyramid. We have the accounts of Herodotus, written more than 2,000 years after Khufu's death, which are colorful and detailed and probably contain a mixture of genuine tradition and creative embellishment. And we have a small ivory statuette, barely 3 inches tall, found at Abydos in 1903, which is the only confirmed portrait of the pharaoh responsible for the most famous structure on Earth. 3 inches tall, one of the great objects of irony in the history of archaeology. Herodotus, writing in the 5th century BCE, describes Khufu as a tyrant. He says that Khufu closed the temples, forced the priests to abandon their duties, and enslaved hundreds of thousands of people to build his pyramid. He says that at one point, when construction funds ran low, Khufu sent his own daughter to a brothel and instructed her to charge a fee for her services, using the income to keep the project going. This is an extraordinary accusation, and most modern historians treat it with considerable skepticism, partly because Herodotus was known to enjoy a good story, and partly because his account of Egypt was written so long after the events that it almost certainly reflects popular legend more than historical record. But it lodged itself in the Western imagination, and for centuries the common understanding of the pyramids was that they were built by slaves, by people who had no choice, driven by a cruel king who cared nothing for human suffering. That understanding turns out to be almost certainly wrong, and the archaeology of the last 40 years has been quietly, systematically dismantling it.
The person most responsible for that dismantling is an Egyptologist named Mark Lenner, who has spent more than 4 decades working at Giza, and who is, along with his colleague Zahi Hawass, probably the closest thing the Great Pyramid has to a dedicated long-term detective. Lenner grew up in North Dakota, became interested in Egypt as a young man, went to study there in the 1970s, and has essentially never left. He is one of those figures in academic life who found his one subject and went into it so deeply and for so long that he has changed it. He has a reputation for being meticulous to the point of stubbornness, which is precisely the quality that archaeology at Giza requires, because Giza rewards patience and punishes shortcuts. In the 1980s and 1990s, Lenner led a series of excavations on the southern plateau east of the pyramid itself, and what he found there fundamentally reframed the conversation about who built the pyramids and under what conditions. He found a city, not a slave camp, not a barracks, a city with bakeries and breweries and butcher shops and medical facilities and administrative buildings and grain silos and workshops for copper tools and workshops for grinding stone and housing for workers and housing for supervisors and what appear to be communal areas. He found evidence that the workers were fed well by the standards of the time. They ate beef and mutton and goat and fish, proteins that were considered luxurious in ancient Egypt and that were not the diet of slaves or prisoners. He found evidence of medical care, bones that had been broken and properly set, skulls that show signs of what appears to be ancient surgery. He found evidence of a rotating labor force, workers who came and worked for a period and then returned to their home villages, replaced by others, a kind of organized national labor draft rather than a system of permanent enslavement.
None of this means that building the pyramids was a pleasant or voluntary experience. The work was brutal, dangerous, and almost certainly deadly for many people. The physical stress visible on the skeletons found in the workers' cemeteries tells a story of bodies pushed to the limits of what human physiology can endure. Arthritis, fractures, compressed vertebrae, worn joints. These were people who labored hard and suffered for it. But they were not slaves in the sense Herodotus described. They were Egyptian subjects drawn from the population at large, organized into crews with names and hierarchies, and apparently a certain amount of identity and pride in their work. Some of the graffiti left by those crews has survived, painted on internal blocks in the pyramid structure, and the names they gave their keems are things like Friends of Khufu and Drunkards of Menkaure. Those are not the names of people who think of themselves as slaves. Those are the names of people who have developed some kind of group identity and are possibly, in some strange way, enjoying themselves, or at least finding meaning in what they are doing. If you're drifting at this point, that's just fine. Let this settle. The pyramids were built by Egyptians for their own reasons, under their own king, in a world that understood all of this very differently than we do. The full story will still be here. Let's talk about that world for a moment, because you can't really understand why the pyramid was built without understanding what the ancient Egyptians believed was happening inside it. Egyptian religion in the Old Kingdom period, which is the era we're talking about, the era of Khufu and his immediate predecessors and successors, was extraordinarily complex and has been the subject of scholarly disagreement for as long as scholars have been studying it. But a few things seem relatively clear, or as clear as things ever get in the study of a religion that was practiced 3,000 years before our era.
The Egyptians believed in the existence of multiple spiritual components that made up a person. The most important of these, for our purposes, was the Ka, which you might think of loosely as a person's life force or vital energy, the animating essence that made a body alive rather than dead. When a person died, the Ka did not simply vanish, it persisted, but it needed somewhere to live. It needed a home, and that home, for an ordinary Egyptian, was the tomb and the mummified body within it. The Ka would return to the body. It needed to eat and drink, which is why tomb offerings were so important. It needed to be comfortable, which is why tomb furnishings were so elaborate. And it needed the body to remain intact, which is why mummification existed at all. For a pharaoh, the situation was considerably more complicated, because the pharaoh was not simply a person, he was also, in the Egyptian understanding, a god, or at least a being with a divine component, serving as the intermediary between the world of humans and the world of the gods, and particularly the god Ra, the sun deity whose journey across the sky and beneath the earth each day provided the fundamental metaphor for Egyptian cosmology. The sun rose, it crossed the sky, it set, it traveled through the underworld, it rose again. Life, death, and rebirth played out in the sky every single day. When a pharaoh died, he was believed to join Ra on that journey, to become, in some sense,
one with the sun. And the pyramid was the vehicle for that transformation. Its shape, the pyramid that tapers to a point reaching toward the sky, was believed to represent the rays of the sun descending to earth, or alternatively, the staircase up which the king would climb to reach the heavens, depending on which aspect of Egyptian theology you're emphasizing and which scholar you're reading. The precision of its orientation, and this is important, was not merely practical, it was cosmic. The Great Pyramid's sides are aligned to the cardinal points of the compass with an accuracy of less than 1/10 of a degree, north, south, east, west. The accuracy is so remarkable that for a long time people assumed it must have required instruments that the ancient Egyptians could not possibly have had. Here's the thing, they probably didn't need exotic instruments. A team at the University of California, Santa Barbara, led by a researcher named Juan Antonio Belmonte, along with other researchers independently, has proposed that the Egyptians may have achieved this remarkable alignment using nothing more than careful observation of the night sky. Specifically, by observing the stars that rotate around the north celestial pole and bisecting the angle they swept through over the course of a night, a skilled astronomer could determine true north with extraordinary accuracy. The Egyptians were meticulous astronomical observers. They had to be, because their agricultural calendar depended on watching the sky, and particularly on the heliacal rising of Sirius, the bright star whose reappearance on the eastern horizon just before dawn each year roughly coincided with the annual flooding of the Nile, which was the pulse of Egyptian civilization. A people who watched the sky that carefully would have had no particular difficulty using it to determine north.
So the orientation was achievable. The question of how they chose the site, surveyed it, leveled it, and the Giza Plateau is remarkably suspiciously level given its size, and began construction is a question that archaeologists have been working at for decades. And the honest answer is that we have good partial answers to some of these questions and genuine uncertainty about others, and the uncertainty is not always where you might expect it to be. Let's talk about the blocks, because the blocks are where most people's imagination gets stuck, and they're worth understanding clearly. The Great Pyramid contains approximately 2.3 million stone blocks. The number gets cited constantly, and it is genuinely staggering, and it becomes even more staggering when you start thinking about logistics. The pyramid was built in approximately 20 years. That's the number that emerges from both the historical record and from modern calculations based on the scale of the workforce and the visible evidence at the site. 20 years, 2.3 million blocks. If you divide those out evenly, you get roughly 800 blocks placed per day, which works out to somewhere between 1 and 3 blocks per minute during a 10-hour working day, every single day for 20 years. That number has been used to argue that the pyramid could not have been built by human beings using only the tools available in the 26th century BCE. The argument has a surface plausibility, it seems like a lot, and it has given rise to a considerable range of alternative theories about who or what was responsible, which we'll get to in due course. But let's sit with the mainstream understanding for a moment, because it is more interesting and more impressive than the alternative theories usually acknowledge. The quarries for the core limestone blocks, the rough interior stones, not the polished casing that originally covered the outside, were located immediately to the south of the pyramid itself, within a kilometer. You didn't need to transport most of the material very far. You needed to organize the quarrying, the shaping, the transport, and the placement of enormous quantities of stone over a very long period of time, with a very large, well-organized workforce. That is a logistical challenge, not a supernatural one. For the outer casing stones, which were made of fine Tura limestone quarried from across the Nile on the eastern bank, and for the granite used in the internal chambers, which came from Aswan, nearly 800 kilometers to the south, you needed boats. Egypt had boats. The Nile was Egypt's highway. Moving heavy stone by water was slow and difficult, but entirely feasible, and there's good archaeological evidence that it was done regularly for large building projects throughout Egyptian history.
For moving the blocks on land, the most widely accepted theory involves sledges, flat wooden platforms on which the blocks were placed, and lubrication. A papyrus scroll found in 2013 in a cave on the Red Sea coast at a site called Wadi al-Jarf is the oldest papyrus ever found,
and it contains something extraordinary. It is the journal of a man named Merer, who was an official overseeing a team of workers during the construction of the Great Pyramid. The Merer Papyrus, as it's now called, gives us an almost day-by-day account of a single work crew transporting Tura limestone from the eastern bank of the Nile to the pyramid site. It describes the boats used, the canals navigated, the locks opened and closed. It mentions supervisors by name. It is a work diary, 4,500 years old, and it is one of the most extraordinary documentary finds in the history of Egyptology. Think about that for a second. We actually have the diary of someone who participated in building the Great Pyramid. Not a legend, not a story told centuries later, an actual account by an actual participant written down at the time. Merer doesn't seem to have found his work particularly miraculous or mysterious. He seems to have found it hard, logistically demanding, occasionally satisfying, and mostly routine. He writes about it the way a middle manager might write about a complicated supply chain operation, which is, when you sit with it, both reassuring and slightly deflating. The Great Pyramid, seen from the inside of the process, was an enormous infrastructure project, a very, very large one, but an infrastructure project. The question of how the blocks were actually raised and placed is where genuine scholarly disagreement still lives, and it is worth understanding why.
The most commonly proposed method, and the one that appears in most textbooks and most documentary films, involves ramps. The idea is that the Egyptians built ramps of compacted rubble and sand up which the sledges carrying the blocks were dragged. As the pyramid grew taller, the ramps grew longer to maintain a manageable angle. This theory has the advantage of using materials and techniques that were definitely available to the Egyptians, and that we can see evidence of at other ancient Egyptian construction sites. The problem is the geometry. A straight ramp long enough and gentle enough in its angle to allow blocks to be pulled to the uppermost courses of the Great Pyramid would itself need to contain almost as much material as the pyramid. The ramp would be enormous, and we haven't found it. Or rather, we've found evidence of ramps at Giza, but not a ramp of the required scale. A French architect named Jean-Pierre Houdin proposed in 2007 a theory involving an external ramp for the lower courses and an internal spiral ramp for the upper ones, which would solve the material problem somewhat. The theory is controversial and has not been definitively confirmed or refuted. Other theories involve the use of multiple smaller ramps approaching the pyramid from different sides. None of these have been conclusively proven.
And here's what's interesting about that uncertainty. It doesn't mean the pyramids are mysterious in a supernatural sense. It means that this specific engineering solution used by the ancient Egyptians has not yet been identified with certainty, because the evidence has not survived in sufficient quantity to settle the question. The tools, the techniques, the labor, all of these were well within human capabilities. The precise mechanism is not yet known. Those are two very different things, and conflating them is the source of most of the confusion that surrounds the pyramids. If you're settling deeper now, letting the images drift, the quarries, the sledges, the boats on the Nile, the crews with their proud names painted on stones, that's exactly right. There's no rush. Let's keep going. The internal structure of the Great Pyramid is its own world, and it is genuinely strange in ways that the exterior is not. When you enter the pyramid today, and visitors can enter, though the experience is not for the claustrophobic, you make your way down a descending passage cut into the bedrock beneath the pyramid, and then eventually up through what's called the Grand Gallery, one of the most remarkable architectural spaces in the ancient world. The Grand Gallery is about 47 meters long and rises about 8.5 meters to a corbelled ceiling, meaning the ceiling is formed by stone courses that step inward on each side, creating a vault. It is not a large space by modern standards, but it is an extraordinary space by any historical standard. The precision of its construction, the way the stones fit together, the quality of the finish, all of it speaks to an almost obsessive attention to craft in a structure that nobody was ever intended to see the inside of, or almost nobody. At the top of the Grand Gallery is the King's Chamber, the room that contained the pharaoh's sarcophagus. The sarcophagus is still there. It is a plain, rectangular granite box, and it is empty. And it has been empty as long as history records. Whether Khufu was ever actually buried there, and if so, what happened to his mummy and to the treasures that would have accompanied him, is one of the unanswered questions of archaeology. The chamber shows no sign of ever having been sealed. The sarcophagus is slightly too large to fit through any of the known passages, which means it must have been placed during construction, not lowered in afterward. But whether it ever held a body is unknown. Above the King's Chamber are 5 spaces, called relieving chambers, that were built one on top of the other to distribute the enormous weight of the pyramid above and prevent the ceiling of the chamber below from collapsing. They have evocative names: Campbell's Chamber, Wellington's Chamber, Nelson's Chamber, Lady Arbuthnot's Chamber, and Davison's Chamber, named after various 19th century explorers and military officers, which is its own small window into the colonial-era history of Egyptology that we'll come back to. These chambers were not intended to be seen. They are rough-hewn, utilitarian. The walls are covered in the original workers' graffiti, including the cartouche of Khufu, placed there during construction by the work crews and never meant for any subsequent human eyes. Which is how we know the pyramid was built for Khufu. The evidence was hidden inside the building itself, waiting.
Now, in 2017, something happened that genuinely captured the world's attention, and that represented one of the more dramatic developments in pyramid research in recent decades. A team of researchers working under a project called Scan Pyramids, using a technique from particle physics called muon tomography, announced that they had detected a previously unknown large void within the Great Pyramid. Muons are particles produced when cosmic rays strike the upper atmosphere. They rain down constantly on everything, including the pyramids, and they are absorbed at different rates by different densities of material. By placing detectors inside the pyramid and measuring the flux of muons from different directions, the researchers were able to produce a kind of density map of the interior, similar in principle to an X-ray. And in that map, they found a large space that no one had previously documented, sitting above the Grand Gallery and running roughly parallel to it. The void appears to be at least 30 meters long and maybe significantly larger. What is it? Nobody knows. It could be an additional relieving chamber, an architectural feature that was decided upon and then left when it turned out not to be needed. It could be a passage. It could be an undiscovered room. It could be a structural anomaly that doesn't correspond to any human intention at all. The muon tomography can tell you that something is there and roughly how large it is. It cannot tell you what it is or what it contains. To know that, you would have to find a way to access it, which would require drilling into the pyramid, which Egyptian authorities are extremely reluctant to permit, both for preservation reasons and for reasons of national cultural sensitivity. The Giza Plateau is sacred in a way that has nothing to do with the supernatural. It is sacred in the way that objects of extraordinary historical importance become sacred when you live in the country that produced them. So the void sits there, unexamined, unknown, another room of the house that we have not yet been allowed to enter.
Let's talk about the Sphinx, because the Sphinx is inseparable from the pyramids, and because it raises its own set of questions that have been contested in ways almost as heated as the pyramid questions themselves. The Great Sphinx of Giza sits on the Pyramid Plateau, east of and slightly lower than the pyramids themselves, carved from a single outcrop of limestone bedrock. It is about 73 meters long and 20 meters tall, with the body of a lion and the head of a human figure wearing a royal headdress. Whose face it represents is a matter of scholarly debate. The most widely accepted view is that it depicts the pharaoh Khafre, who built the second pyramid, because the Sphinx appears to be oriented toward Khafre's funerary temple complex, and because the features of the face, to the extent they can be compared to anything, are sometimes argued to match Khafre's other representations. But the face has been so severely damaged over the centuries, partly by erosion, partly by deliberate defacement at some point in antiquity that remains mysterious, that confident identification is difficult. What we know with relative certainty is that the Sphinx is old. The context in which it is embedded, the Valley Temple to the east, the causeway running up to Khafre's pyramid, places it firmly in the 4th dynasty, around 2500 BCE. What we don't know with certainty is whether it was carved during Khafre's reign specifically, or during Khufu's reign and then associated with Khafre's complex later, or at some other time entirely. The archaeological context favors Khafre, but the evidence is not absolutely conclusive. And then there is the water erosion hypothesis, which is the most controversial claim in mainstream Sphinx scholarship of the last 30 years, and which is worth understanding carefully because it illustrates something important about how scientific debates work and how they can be misrepresented.
In the early 1990s, a geologist named Robert Schoch, working with a writer named John Anthony West, made a claim that caused considerable excitement. Schoch looked at the erosion patterns on the body of the Sphinx and on the walls of the enclosure it sits in, and he argued that the erosion was characteristic of water erosion rather than wind and sand erosion. And the only time in the relatively recent geological past when enough rain fell in the Giza region to produce water erosion of that kind was the period before roughly 5000 BCE, possibly going back as far as 7000 BCE. If the Sphinx showed water erosion, and if water erosion in that region required rain, and if the region was last rainy before 5000 BCE, then the Sphinx might be significantly older than the 4th dynasty, perhaps 2000 years older, perhaps more. This claim was taken seriously by some geologists and almost universally rejected by Egyptologists, and the debate between those two camps was sharp enough to generate actual public arguments at academic conferences, which in the normally sedate world of Egyptology counts as dramatic. The geological argument for water erosion was not unreasonable on its face. The Egyptological counter-argument was equally not unreasonable. There is simply no archaeological evidence whatsoever for a civilization capable of carving the Sphinx before 3000 BCE in the Nile region. The civilization that built the Sphinx left artifacts, documents, pottery, administrative records. If there were an earlier civilization that built it, it left nothing. And absence of evidence at that scale over that breadth of excavation and survey is itself a kind of evidence.
The mainstream consensus today, which is the consensus of virtually all active Egyptologists and most geologists who have examined the question, is that the Sphinx dates to the 4th dynasty, approximately 2500 BCE, and that the erosion features Schoch described can be explained by mechanisms other than heavy rainfall. But the claim has persisted in popular culture in ways that have little to do with the state of the evidence, because it speaks to something people find genuinely compelling, the idea that there was an earlier, lost civilization that preceded the Egypt we know. That idea is old. It surfaces in a slightly different form in almost every century of recorded Western thinking about Egypt, and understanding why it has such persistent appeal is, I think, genuinely interesting and worth taking some time with. Let's go back to the 19th century for a moment, because that's when the modern mythology of the pyramids really crystallizes, and it crystallizes around a series of writers and thinkers who were not archaeologists in the professional sense, but who had very strong feelings about what the pyramids meant, and who wanted those feelings to be true badly enough to reason backward from the conclusion. Napoleon's expedition to Egypt in 1798 is the usual starting point, and it is an extraordinary moment in history for reasons that go well beyond the pyramids. Napoleon brought with him not just soldiers, but a team of scientists and artists and scholars, about 150 of them,
who were charged with documenting Egypt systematically and comprehensively for the first time in modern history. The result of that documentation was a massive publication called the Description de l'Égypte, which appeared in 23 volumes between 1809 and 1829, and which introduced educated Europeans to ancient Egypt in a way they had never encountered before. The scale of the ruins, the extraordinary state of preservation, the sheer antiquity of the civilization. Europe became obsessed with Egypt, and that obsession gave rise, over the following century, to a field of scholarship that was genuinely productive and to a parallel tradition of popular theorizing that was genuinely strange.
One of the strangest and most influential figures in that popular tradition was a Scottish writer named Charles Piazzi Smith, who was the Astronomer Royal of Scotland in the 1860s, and who became absolutely convinced that the Great Pyramid was a divinely inspired monument whose measurements encoded a vast range of scientific truths and prophecies. Smith spent considerable time at Giza, measuring and remeasuring the pyramid to extraordinary decimal place precision, and then finding in those measurements confirmation of everything from the precise value of pi to the distance from the Earth to the Sun, to a timeline of human history stretching from the Exodus to the Second Coming of Christ. The methodology Smith used, and that his followers continued to use after him, has a name in skeptical literature: pyramidology. And pyramidology works by a principle that sounds scientific, but isn't. You have an enormously large, precisely built structure with many measurable dimensions. You multiply, divide, add, and subtract those dimensions in various combinations until you get a number that matches some other number you were hoping to find. The precision of the pyramid means that almost any sufficiently creative mathematical operation on its dimensions will eventually yield something that resembles something else: the sun's distance from the Earth, the speed of light, the weight of the planet, the year of the Battle of Waterloo, the precise value of something called the pyramid inch, which Smith invented specifically for this purpose, and which does not correspond to any ancient Egyptian unit of measurement that archaeologists have ever found.
Smith's pyramidology was enormously popular in its time. His book, Our Inheritance in the Great Pyramid, went through multiple editions and was widely read. It inspired a movement. It inspired legislation. A British member of Parliament actually introduced a bill in the 1860s to make the pyramid inch the basis of the British measurement system, on the grounds that it was the divinely inspired unit embedded in the structure. The bill did not pass, but the movement persisted. And here's the thing. The tradition of finding meaning in the pyramid's measurements, of treating the structure as a kind of encoded message from a more ancient and more knowing civilization, did not die with Smith. It mutated. It went underground, in a sense, and re-emerged in the 20th century in a different form, but with the same basic structure. The pyramid is too perfect to have been built by ordinary ancient Egyptians. Therefore, it must have been built by someone or something else, and the measurements prove it. The 20th century version of this tradition owes a great deal to two writers in particular, Erich von Däniken and later Graham Hancock. Their approaches are different in tone. Von Däniken's Chariots of the Gods, published in 1968, is breathless and sensational and credits ancient aliens directly, while Hancock's Fingerprints of the Gods, published in 1995, is more measured and attributes the pyramids to a lost advanced civilization rather than extraterrestrials. But the underlying argument is similar in structure. The pyramids are anomalous. They are too precise, too large, too sophisticated for the civilization that supposedly built them. Therefore, something has been left out of the conventional account.
The problem with this argument, and it is a fundamental one, is that it is not actually an argument about the evidence. It is an argument about what we feel should be possible. And feelings about what should be possible, however sincerely held,
are not evidence. The Egyptians documented themselves obsessively. They left administrative records, work schedules, papyri describing logistics, graffiti from work crews, physical evidence of quarrying and transport and construction. The evidence that they built the pyramids is as well documented as almost anything in the ancient world. The claim that they couldn't have built the pyramids, and that therefore someone else must have, requires you to ignore or explain away an enormous body of direct evidence in favor of an indirect argument from incredulity. None of that means the pyramids aren't astonishing. They are. They are one of the most astonishing things that human beings have ever done. But human beings are astonishing. That is the actual lesson, and it is a better one. Let's talk for a while about the people who devoted their lives to understanding the pyramids, because the history of Egyptology as a discipline is its own kind of story, complicated and interesting in ways that go beyond the pyramids themselves.
Giovanni Belzoni is one of the more colorful figures in the early history of pyramid research. He was Italian, born in Padua in 1778, and he was by any measure an extraordinary physical specimen, 6 feet 6 inches tall, enormously strong, and possessed of a relentless drive that seems to have been temperamentally unable to rest. Before he ever thought about Egypt, Belzoni was a circus performer in England, performing feats of strength and build as the Patagonian Samson. He came to Egypt in 1815 to propose a new water-lifting device to the then ruler of Egypt, Muhammad Ali, and when the proposal was rejected, he stayed anyway and began working as an antiquities collector for the British consul Henry Salt. He opened the temple of Abu Simbel. He discovered the tomb of Seti I in the Valley of the Kings, and in 1818 he forced his way into the Pyramid of Khafre, the second pyramid, which had never been opened in modern times. He described the experience in his published account with a kind of exhilarated modesty. He found it extraordinary. He found it empty. He sat in the burial chamber and tried to imagine what had been there and when it had gone, and the silence of the chamber was so complete that he could hear his own heartbeat. Belzoni died in 1823 in West Africa of dysentery while attempting to find the source of the Niger River, because of course he was. He was 45 years old, and he had packed more into those years than most people manage in twice that time. The great systematizer of Giza, the man who brought genuine scientific method to the study of the pyramids, was the British engineer and archaeologist Flinders Petrie, who came to Giza in 1880 specifically to test Piazzi Smythe's measurements. Petrie was a young man at the time. He was 27, and he had been raised in a household where pyramid numerology was taken seriously. His father was a surveyor who had planned to go to Egypt and measure the pyramid himself, and Petrie had grown up on these ideas. But Petrie was also at his core a scientist, and when he actually measured the pyramid with the most precise instruments then available, what he found was that Smythe's measurements were not quite right. The numbers Smythe had used to derive his cosmic correspondences were off, not by much, but enough to make the correspondences fail. Petrie published his results, gently but clearly, and they were devastating to the pyramidology tradition. Petrie went on to become one of the greatest archaeologists of his generation, one of the founders of systematic archaeological method, and his work at Giza established the basis for much of what followed. He was also, by contemporary accounts, a genuinely unusual person who lived and worked in conditions of remarkable austerity, sometimes spending months in the Egyptian desert subsisting on tinned food and working through the heat of the day in conditions that shocked his colleagues. He reportedly worked in his underwear to stay cool, which shocked the Victorian sensibility of visiting dignitaries. He did not care. The monuments required attention, and the heat was a distraction, and clothing in the heat was another distraction, and Petrie had limited patience for things that got between him and the work. Let's come back to what we actually know and what we don't, because the conversation has been threading between those two things, and it's worth trying to be clear. What we know, the Great Pyramid was built approximately 4,500 years ago, during the reign of the pharaoh Khufu of the 4th dynasty of ancient Egypt. It was built by Egyptian workers, organized into crews, who were fed, housed, and medically cared for on or near the construction site. The core limestone came from quarries immediately adjacent to the pyramid. The fine casing limestone came from Tura, across the Nile. The granite used in the internal chambers came from Aswan. The materials were transported by sledge and boat. The site was leveled, oriented, and surveyed using techniques available to the ancient Egyptians. The construction probably took approximately 20 years. The project was an act of religious and political will, an expression of the pharaoh's divine status and his relationship with the sun god Ra, and a mechanism intended to facilitate his transformation in death.
What we don't know: the precise method used to raise the blocks, the full extent of the internal structure, including the nature of the newly discovered large void, whether Khufu was ever actually buried in the king's chamber, and if so, what happened to his remains and his burial equipment, exactly how many workers were involved, and how they were organized at the highest level of the project, the precise tools used to achieve the extraordinary precision of the fit between casing stones, the specific sequence of construction, the full range of what the pyramid was meant to achieve in the Egyptian theological imagination. Those unknowns are real and significant. They represent the limits of what 4,500 years of time and the loss of records and the continuous occupation and modification of the site have allowed us to know. They are not evidence of alien intervention or of a lost civilization. They are evidence of how hard it is to fully understand something very old, very large, and very complex, across a gap of time that makes every human lifetime seem insignificant. There is one more thing worth spending some time on, and that's the question of the other pyramids, because the Great Pyramid does not stand alone at Giza. And the story of why the 3 Giza pyramids are arranged the way they are has generated its own tradition of interpretive speculation.
The 3 pyramids are those of Khufu, of his son Khafre, and of his grandson Menkaure. Khufu's is the largest. Khafre's is slightly smaller, but sits on higher ground, which gives it the appearance of similar height from certain angles, and which has confused casual observers for centuries. Menkaure's is considerably smaller than either of the first 2, about 60 meters tall compared to the original 146 of Khufu's, and it feels like a statement of either humility or changed circumstances, depending on how you interpret the evidence. In 1994, a Belgian engineer named Robert Bauval published a book called The Orion Mystery, in which he proposed that the layout of the 3 Giza pyramids, and particularly the slightly offset alignment of the 3rd pyramid relative to the other 2, was intended to mirror the 3 stars of Orion's belt as they appeared in the sky around 10,500 BCE. This theory, sometimes called the Orion correlation theory, became enormously popular and was enthusiastically taken up by Hancock and other writers in the alternative history tradition. The idea is aesthetically compelling. The Egyptians were certainly avid astronomers, and the connection between the pharaoh's afterlife journey and the stars was a central element of Egyptian religious belief.
The problem is that the correlation, when examined closely, is not as precise as it looks in the diagrams in Bauval's book. The arrangement of the pyramids does loosely resemble the arrangement of the 3 belt stars, but the match is imprecise, and you can achieve similar apparent correspondences between the arrangement of many sets of 3 objects and many sets of 3 stars, if you're willing to adjust the scale and orientation. More significantly,
The date of 10,500 BCE is chosen because that's when the stars of Orion's belt were at their lowest point in their precessional cycle. But there is no archaeological evidence connecting the Giza site to that period, and the construction of the pyramids in the 4th dynasty is very well documented. The theory requires you to believe that the Egyptians of 2500 BCE were building a monument to commemorate a celestial arrangement that was most accurate 9,000 years before their time, for reasons that are not explained. Egyptian archaeologists and mainstream astronomers have largely rejected the theory, but it persists in the same way that pyramidology persists and the water erosion theory persists, because it speaks to something in us that wants the pyramids to be more than they are, as if 4,000 years of survival and the sheer scale of human will and labor that produced them were not enough, as if the real accomplishment of the ancient Egyptians required a cosmic confirmation that they, on their own, with their sledges and their copper chisels and their astronomical observations and their papyrus work diaries, were not quite sufficient to have done it.
And this, I think, is the most interesting thing about the pyramids and their history. Not the void, not the water erosion, not the alignment. The most interesting thing is us, the long human conversation with these structures, the way every generation has projected its own anxieties and ambitions and frameworks of meaning onto them. The ancient Greeks who thought they were treasure houses, the medieval Arab scholars who thought they were repositories of lost wisdom from before the flood, the Victorian numerologists who thought they were divine calculators, the 20th century alternative historians who thought they were memories of Atlantis or messages from Orion, the 21st century physicists who are sending cosmic particles through them to map their interiors. All of these responses tell you something real about the people having them, and something real about the pyramids, because the pyramids are large enough and old enough and sufficiently resistant to complete explanation to accommodate all of these projections while remaining at the core themselves. Let's slow down now. You've been listening for a long time, and the light has been going dimmer. There is a man named Mark Lenner, we mentioned him earlier, the archaeologist from North Dakota who has spent 4 decades at Giza, who was asked in an interview once why he had devoted his life to this particular subject when there were so many other subjects in the world. And he said something that I've thought about often. He said that the pyramids are a kind of mirror, that if you ask what they mean, you will eventually find yourself asking what you mean, what any of us mean, what we're all doing here, and how long any of it lasts. He said this without any mysticism. He said it the way someone says something they have found to be practically true, through long experience.
I think he's right. There's something about the scale of what those workers built, the physical reality of millions of stone blocks moved by human muscle, organized by human will, serving a purpose defined by human belief about death and transformation. Something about all of that, sitting in the desert unchanged for 4,500 years, while everything else changed around it, speaks to a question that has no answer, but keeps being asked anyway. What persists? What survives? What was it all for? The pharaoh's body is gone. The treasures are gone. The priests who chanted the prayers are gone. The scribes who kept the records are gone. Merer, with his careful diary of boats and canals and limestone blocks, has been dust for longer than we can emotionally comprehend. Even the name Khufu, which appears on those blocks inside the pyramid, is only known because it survived inside the structure, protected from light and air and the passing of generations.
outside the pyramid. The world dissolved it, as it dissolves everything, eventually. But the pyramid is there, right now, in the dark, on the edge of Cairo.
That's a lot to know, and it's not everything. And maybe that combination, knowing enough to feel the humanity of it, not knowing enough to feel its full weight, is exactly what the pyramids are, and what they've always been. You don't need to hold on to any of this. Let the names go. Let the numbers go. Let the quarries and the boats and the graffiti and the void and the Sphinx and Belzoni in the burial chamber with his heartbeat all go. Let them drift out into the dark, where they've always been, patiently. The pyramids will still be there in the morning, and so will all the questions. Sleep well.